Okay, welcome back to tissues. So part two is going to cover connective tissues, and then part three will be muscle, nervous tissue, and then cutaneous membranes and tissue repair. Um, Trying to break this up into smaller parts in case you're studying and listening to me. You can sort of take little breaks in between these little subunits here. So I will most likely get to the part three tomorrow and the integumentary system tomorrow morning. I'll have both of those posted for you guys. Okay, so connective tissue. This is the most abundant and widely distributed of the primary tissues throughout the body. It is also the most diverse. Major functions of connective tissue include binding and support, protection, insulation, storing reserve fuel, and transporting substances, such as what we see with the blood. There are four main classes of connective tissue. There's what we call connective tissue proper, cartilage. You'll see that there's three types of cartilage, bone, and then blood. There's two types of bone. Looking at the different types of connective tissues here, this is a nice table from your textbook that sort of looks at the comparison between the connective tissue proper, where we have loose connective tissue and dense connective tissue. It also summarizes the cells that are present in that type of tissue, what the matrix looks like. We'll talk about cells and matrix in a second, and the general features of that type of connective tissue. Cartilage, as I mentioned, there's three types of cartilage. Again, what type of cells, matrix, general features. This is actually a great, if you're making index cards to study or if you're making notes for yourself, this really just has that information all front and center out there. Bone tissue, as I mentioned, there's two types of bone tissue, compact bone and spongy bone. And again, the cells, matrix, and features. And then finally, blood, the cells, and then the features. So there are three characteristics that make connective tissue different from your other primary tissues. They all have common embryonic origin, meaning they all come from the same, essentially same stem cells. They have varying degrees of vascularity. Cartilage is avascular, okay, but if you look at something like bone tissue, which a lot of people don't realize, it's highly vascularized. You realize that if you actually broke a bone and how much you swell out from that broken bone and the hematoma that forms. Cells are suspended or embedded in an extracellular matrix. This is a protein sugar mesh that's formed and secreted by the cells. The matrix supports the cells so that they can bear weight, withstand tension, and endure abuse. Okay. We do not see this matrix with the other types of tissues, such as epithelial, muscle, and nervous. This is something that is unique to connective tissue. If you remember, with epithelial tissue, which was the prior lecture, that was mostly involving cells with very little, with not many other substances. Here, you might look at some of these connective tissues and actually find very few cells, but a lot of matrix. So the structural elements of connective tissue, they're going to have three main elements, what we call ground substance, fibers, and cells. Ground substance is going to be an unstructured gel-like material that's going to fill the spaces between cells, essentially everything in between the space of the cells. Components of ground substance can include interstitial fluid, cell adhesion proteins. These cell adhesion proteins will act as the glue for attachment. Proteoglycans, or sugar proteins, which are made up of protein core and large polysaccharides. These proteoglycans tend to be the outer coverings of a lot of cells. Water also is trapped in varying amounts, also affecting the viscosity of the actual ground substance. There's also going to be what we call connective tissue fibers, and there's three types of fibers that are going to function primarily in support. collagen fibers. These are the strongest and the most abundant type. They are tough. They provide high tensile strength, and they're really there for that strength. Elastic fibers, these are networks of long, thin elastin fibers that allow for a little bit more of a stretch and recoil. And then reticular fibers, these are short, fine, highly branched collagenous fibers. Different chemistry and form than we see with the collagen fibers. This reticular fibers, you're seeing more of a branching network. Okay, you know, that actually just gives a little more give actually to the tissue. The different types of cells, blast refers to cells. So we have fibroblast. The fibroblasts are going to be found in connective tissue proper. Chondro means cartilage. Chondroblasts are found in cartilage. Osteo means bone. These will be found in the bone cells. As I mentioned, all of these types, and then you have various blood cells such as your erythrocytes, leukocytes, which will be found in blood, and platelets. All of these cell types actually derive from what we call the hematopoietic stem cells, okay? And these are actually, the hematopoietic stem cells are what give rise to the blood cells, the leukocytes, the erythrocytes, and the platelets. When you see the term cyte, that is actually a mature, less active form of the blast cell that now becomes part of and helps to maintain the health of the matrix. Other cell types that we find in connective tissues, fat cells will store nutrients, white blood cells, neutrophils, eosinophils, lymphocytes. These are involved in immune response. Mast cells, these will initiate local inflammatory responses against foreign microorganisms that they detect, and macrophages, which would be an example of a phagocytic cell. Phagocytosis being a process in which you have a cell that would engulf, say, another cell or a bacterial cell or a microorganism and digest it through lysosomal activity. Okay. So again, the three things that make up connective tissue are the fibers, the ground substance, and the cells. And let's look at the four different types or families of connective tissue. So with the connective tissue proper, this consists of all connective tissues except bone, cartilage, and blood. And we break this up into loose connective tissue, which includes areolar, adipose, and reticular, and dense connective tissue, which includes dense regular, dense irregular, and elastic. Areolar connective tissue, this is the most widely distributed connective tissue in the body. And this is the type of connective tissue that you'll probably see surrounding most soft tissue body organs. It helps to support and bind other tissues together. Another way to think about this is that it's the quote-unquote universal packing material between other tissues. It does contain fibroblasts as it's part of the connective tissue proper that secrete loose arrangement of mostly collagen fibers. So that's the type of fiber you're primarily going to see in this type of tissue. The loose fibers allow for an increased ground substance. Remember, that's the filler, which can act as a water reservoir by holding more interstitial fluid. Macrophages and fat cells can be contained within these spaces. And, you know, for abdominal fat, this is where you tend to accumulate a lot of that fat. Here's an image. You can see these little purple specks. These are going to be the fibroblast. You can see these long strands. These are going to be some elastic fibers, and then you can see these thicker purple strands, these, which is mostly what you're seeing here. These are going to be your collagen fibers. So we do see some elastic fibers here. we see some more of an abundance of collagen fibers and in our fibroblast. Adipose tissue, this is white fat. It's similar to areolar tissue, but greater nutrient storage. The cells are called adipocytes. It has very little matrix. It's not much at all. Fat is highly vascularized, and it functions in shock absorption, insulation, and energy storage. Brown fat is used lipid fuels to heat the bloodstream rather than produce ATP. And what you end up seeing with adipose tissue is that you sort of look like these big air bubbles here. And with inside these adipocytes or adipose cells, you have lipid deposits. Reticular connective tissue, this resembles that of areolar, but the fibers are thinner, reticular fibers. The fibroblasts are going to be cells called reticular cells, which the reticular cells will secrete reticular fibers made up of thin collagen. The reticular fibers will form a mesh-like stroma that acts as a support for blood cells in lymph nodes, spleen, and the bone marrow. And here what you're seeing is these branching reticular fibers, and you can see the various fibroblast cells that are dark staining structures here. Looking at our dense connective tissue, which is part of connective tissue proper, we have dense regular, irregular, and elastic. Dense regular connective tissue, it has very high tensile strength. It can withstand high tension and stretching. You have closely packed bundles of thick collagen fibers that will run parallel to a direction of pull. You have some fibroblasts present, very few cells, and ground substances is mostly collagen fibers. It's poorly vascularized, and when you look at this, you can see very few cells here and there, but mainly just a bunch of collagen fibers all going in one direction. So if you were to pull this tissue in this direction or in this direction, you'd have a lot of tensile strength. The problem with dense regular connective tissue is that when you pull in this direction or downward, upward or downward, you're going to tear that tissue pretty easily. It's going to pull right along that those parallel fibers there. We typically will find this type of tissue in tendons and ligaments, and that's why when you sometimes move a appendage in a direction that it necessarily should not move, the tendon and ligament can tear pretty easily. In some of your joints where you have more range of motion, you probably will not have dense regular, but rather dense irregular. It's very similar to dense regular, except the fibers are going every which direction, which just gives you more of stability on the tensile strength from no matter which direction you're going to pull. Elastic connective tissue. Some ligaments are very elastic. You're going to have a lot more elastic fibers present. This type of connective tissue would be found in the walls of many of the larger arteries. Arteries need to stretch when blood enters and recoil to push blood out. And here you can see this is the elastic wall of the aorta. So this is the wall of the aorta. Here you can see all of the elastic fibers, and this allows for that particular blood vessel to sort of expand out when the heart pumps and then sort of recoil back during relaxation periods. Okay, so those are the 6 different types of connective tissue proper. The next type of connective tissue is cartilage. Cartilage is a matrix secreted from chondroblast during growth and chondrocytes, which is what we see in adults. Chondrocytes are found in cavities called lacuna. 80% water with packed collagen fibers and sugar proteins, though yet not tough. It's a tough tissue, yet flexible material that lacks nerve fibers. All cartilage will be avascular, okay? And there are three major types of cartilage. We have hyaline cartilage. This is the most abundant. And in some animals, this is what you would refer to as gristle. It appears as a shiny bluish glass appearance. It's found at the tips of long bones, your nose, your trachea, the larynx, and the cartilage of the ribs. The cartilage that actually attaches the ribs to the breastbone. Elastic cartilage, this is similar to hyaline cartilage, but with more elastic fibers. This is found in the ears and in the epiglottis. So this is why you can sort of take your ears and, you know, twist them all around and they go right back to where they were. The epiglottis, this is a flap that is found at the interchange between the esophagus and the trachea. When you swallow, what happens is the epiglottis will block the trachea so that food has only one path to go down, which is down the esophagus. And essentially the epiglottis prevents you from choking. Fibrocartilage, this is actually going to contain properties somewhere between hyaline and dense regular tissue. It's strong, and it's found in areas such as the intervertebral disc and within the knee. The intervertebral disc is the space between two vertebrae in your spine. So I want you to think about your vertebrae. Your vertebrae function to, we haven't gone over this yet because we haven't got the skeletal system, but your vertebrae function to sort of withstand and take the weight of the body, okay? And the knees are also taking a lot of the weight of the body. So you're going to find this fibrocartilage in areas where you have a lot of tensile strength that's needed. The thing with cartilage is that, you know, cartilage tends to prevent bone-on-bone interactions, which is something that you definitely want. When you start to lose some of this cartilage between some of these bones, that's when you have, you know, disorders such as arthritis, which is a lot of pain. So this is looking at hyaline cartilage. Again, hyaline cartilage is going to contain lots of collagen fibers, okay, with a nice matrix. You can see the cells located in the lacuna. Elastic cartilage is going to contain more elastic fibers, less collagen fibers, and again, you still have the cells within the lacuna. And then the fibrocartilage, this is going to contain thick collagen fibers, similar matrix to that of what we see in hyaline, but a lot less firm. Okay. Bone tissue. Bone tissue is also called osseous tissue. It helps to support and protect body structures. It stores fat and synthesizes blood cells in cavities, has more collagen compared to that of cartilage, and its matrix is going to contain inorganic salts such as calcium salt. Osteoblasts are cells that produce matrix. Osteocytes, which are actual bone cells, maintain the matrix, and they will also reside in cavities called lacunae. An osteon is an individual structural unit that we'll talk about with bone tissue, which I believe is chapter 6. And bone tissue is highly, highly vascularized. And here's what bone tissue looks like. Okay, this is actually going to be compact bone, where you can see this would actually be one this would actually be one osteon unit right here. Okay, these concentric rings of bone tissue. When we get to bone tissue in chapter 6, we'll look at the differences between compact bone and spongy bone. Blood. Blood is the most atypical connective tissue because it is actually a fluid tissue. It consists of cells surrounded by a matrix, which is called the plasma. Red blood cells are the most common cell type that's found in blood. If you were to actually, prick your finger and do a blood smear, which you would see looking underneath the microscope are mostly red blood cells. They also contain white blood cells and platelets. The fibers are soluble proteins that precipitate during blood clotting. And the main function of blood is to function in transport and in carrying nutrients, waste, gases, and other substances. And here is an image of a blood smear where, again, what you're looking at mostly here, these little red dots, these are all red blood cells. These big purple things are your occasional white blood cell that you might find, and these little purple specks are platelets. Okay, and this is where I'm going to end part 2 of the tissues lecture. As I said, the remainder of this chapter will be finished up in part 3, and I will post that one tomorrow if you are sort of synchronously listening to these lectures. If not, it may already be up there, and you can go right ahead and listen to it. Have a good day, guys.